Welcome to Automated Visual Software Analytics. This part is about the software map theme, quality improvements. In this part, we will briefly characterize quality improvement and quality improvement measures. We will see how software maps can depict quality improvements, and we will discuss their application and some actionable insights that can be gained by this specific kind of software map. Let's start with quality improvements and their characteristics. Quality improvement measures in a software development process are largely invisible to non-technical stakeholders and sometimes even to technical stakeholders, and thus are difficult to communicate and to discuss. Internal quality of code is largely invisible and even intangible. For that reason, it is difficult to convince the management and to create awareness in general. So we need effective instruments that support us and facilitate, for example, to monitor the progress of quality improvements, the progress of quality improvement measures that have been adopted, or to assess the actual success in practice. Quality improvements also have sometimes compete with feature delivery. To explain this phenomenon, effort spent by developers on improving the internal quality of code is hardly recognized, and developers in general do not receive appreciation for their efforts if they spend these efforts on improving internal quality of code. This leads to various consequences. For example, to shifting the focus on feature delivery with decreasing care on internal code quality, because delivered features are tangible, delivered features are visible, can be recognized, and most likely they will be appreciated, for example, by customers. If quality improvement cannot be communicated and is not recognized, then it will be difficult to motivate work on quality improvements. How can we solve this situation? The software map can help us by making visible aspects of quality improvements. In the following example, we see part of the Android operating system, and the software map depicts quality improvements. It uses logical lines of code as a base measure for each source code unit, and then it correlates two important informations. One is the nesting level complexity as a general measure of software complexity. This is mapped to the height of a cuboid. And the other information dimension used is the number of weeks with changes observed over a period of time of 1 year. For example, the red tall cuboids indicate software module source code units that have a high level of nesting and, due to the red color, have been changed in a large number of weeks throughout the year. For example, up to 21 weeks in this example. So we correlate a technical software quality metrics, nesting level, and let's say an evolution-centric metric, the number of weeks in which changes occur to the software system. This easily outlines, for example, those modules that have a high complexity and are under heavy redevelopment or, for example, bug fixing. So we can easily identify these hotspots that can be used to argue about quality improvements. Let's see how this works. Later, let's have now a look on even a further aspect of this kind of software map. We can even project and make visible the progress of software quality improvements using extended visual variables available for software maps. In this case, we use the top facets of the cuboids. They are colored yellow or green. Both colors indicate a certain trend. Yellow indicates a trend towards the negative, the worse, while green indicates a trend towards the positive, the better. And the horizontal stripes visualize the change regarding the underlying software metrics, in this case a nesting level. So we can use the software map not only to communicate a as-is situation, but also to express the trends underlying this software system and its development. Yeah, how are these maps, software maps, are composed? As already said, the logical lines of code mapped to the cuboid's footprint size is used to expose monolithic code as a first general indicator to code that is hard to manage. In the nesting level 4+, the lines of code are used and mapped to the cuboid's height to indicate complex, potentially error-prone code. The number of weeks with changes throughout the observation time related to bug fixes is used to show how frequently bug fixes have been applied to source code units, and it's mapped by a color schema. Difference in height, respectively the nesting level, to a previous code snapshot or version are mapped to colored top faces and horizontal stripes. So green is used to indicate change for the better, while yellow was used to indicate a change for the worse in this example. Yeah, the software maps that highlight quality improvements also give us an example about how to map metric value differences between two versions of a source code by means of these extended visual variables of a software map. The horizontal stripes are used to assess the progress in terms of reducing, increasing the software quality measures. Both the relative as well as the absolute differences can be assessed this way. So this is an example of a software map that uses the advanced features with respect to the visual variables they have. Now let's see typical use cases and applications of this software map theme. It's used to monitor quality improvement over time, to communicate the result of efforts spent on improving the internal quality to the management. Potential conclusions and way of proceeding includes the support for the management of long-term software quality improvements. It's also used to assess progress and control whether the development trends are still aligned to the software quality goals defined for a project, for example. The software maps also document effects of investment in software quality. What happened after the investment have been made? Has it actually consequences on the internal code quality? Yeah, and it communicates success and progress of quality improvements initiatives to the management. So it's a good communication medium for this specific aspect, improving internal code quality related to bug fixing activities. Yeah, this concludes this part. Let's summarize the main findings. The software map theme quality improvements can be applied to monitor, to evaluate, also and primarily to communicate the status and trend of quality improvements, as well as the effect of efforts spent to quality improvements. With this software map theme in particular, we can precisely show the progress of implementing measures to improve quality with respect to appropriate key indicators, such as different software quality metrics, for example, the nesting level. Of course, other software complexity metrics can be used as well, depending on the kind and nature of the underlying project. As actionable insights, this type of software map allows us to intervene in the case adopted measures to quality improvements are not on track. We can also effectively control that teams actually make progress. This software map theme, furthermore, helps to decide whether the overall software quality of a system is up to standard. This concludes this part about the software map theme quality improvements.